hear me. I'm gonna scream. Okay, can you zoom that in for me really quick? So, welcome to our Arduino Foundations workshop, or Arduino Fundamentals. I forgot what we called it. As always, I'm gonna give my little spiel about Explore and the cohorts. If you've heard it before, please just bear with me. And if you haven't, please pay attention, because this one is really important since this is the first cohort workshop for hardware. So there's a survey for you guys to fill out in order to get your merch at the end. So what is Explore? Explore essentially centers on 4 main tracks: web dev, game dev, AI, and hardware. It's a series of workshops that will help you develop your skills in these tracks and help you actually create projects that you can put on your GitHub and your resumes throughout 3-4 weeks, depending on the track. So everyone is welcome to attend all of the Explore workshops at any given time, but this time we're doing a cohort style. They've all closed already. So if you guys are here, you've likely applied for the hardware track and maybe for some of the other ones as well. You can apply for 2 tracks at a time. If you didn't get a chance to, or it doesn't work with your schedule, or you guys want to do more, we're gonna repeat all of these workshops after spring break. And if you didn't sign up, don't worry, you're still welcome to come and learn. It's open to everyone. It's just kind of an incentive for us to see how we're doing with the program, keep the engagement up, and see how we can improve for you guys for next iterations. So if you scroll down for me, we have this cohort entry form. So I want all of you guys right now to scan this. If you've already scanned it for another track, don't worry about it. But if you are part of, I think for all the other ones, you should have already filled it out. So if you're part of another one, don't worry about it. If you're only part of hardware, go ahead and fill this out now. This is mandatory for you guys to get your Explore merch at the end. If you come to all 3 of the workshops and you fill out my 2 surveys, then you get your merch. So I'll give you guys a second. And then I should have said the other thing about I'll say the thing about the other thing while they're filling it out. While you guys are filling that out, I'm going to let you know that we have our Explore Hub. Can you scroll up? Up. We have our Explore Hub, which is basically your one-stop shop for Explore. So it's go.fiu.edu/ExploreHub. There's where you're going to find all of your Notion docs, all of your live streams, PowerPoints, basically all the documentation that you guys need. So if you fall behind or if you need some extra, reinforcement on the topics that we're covering, you guys can go ahead and see that there. If you guys have not downloaded your Arduino IDE, which you need for this workshop, you can go to that Explore Hub. Again, it's go.fiu.edu/ExploreHub. And under the hardware section, you'll see both of the Notion pages for the previous workshop and this workshop will have a link to download Arduino IDE. So please go ahead and do that while we're kind of doing our intros and stuff, so you guys can be caught up by the time we start with the projects. Has everyone filled out the form? Yes?
Everyone checked in already?
If you haven't checked in, I think, well, you just walked in, so I'll check you in. If you guys haven't checked in, I'll ask again at the end and keep your hands raised for me just in case. So then I'm gonna go through some of our upcoming events for this week. If you guys are interested, we have our last web dev workshop. I'll get you, don't worry. We have our last web dev workshop tomorrow at 3:30 p.m. in VH 131. You're finalizing your Spotify visualizer. They're gonna go through APIs, finalizing, I think, all of your HTML, CSS, and JavaScript code, and pushing all that to GitHub and actually deploying. So really interesting. Even if you haven't gone to the other ones, you guys can catch up on that Explore Hub and go check it out. You might be interested. So then we also have our AI workshop. It's Create a House Price Predictor. That's going to be on Wednesday at 4 p.m. in PG5 134. And that's going to be really interesting because, again, you're going to have a full-fledged project that you guys can put on your resumes, on your GitHub. And it's important to start building these stuff up because once you start applying, they're going to start looking for not just your education, but also your personal projects. So, yeah, that's basically it. I'm going to hand it over to Franco, and you guys can get started.
Hello, everyone. Oh, well, I have to put this first.
And I would maybe use that one.
Yeah. Yeah. Yeah, put it like, how are you now? You put me, now I'm nervous because of the chocolate, yeah? All right, so welcome everyone to this first official workshop from the cohort. Although I see a lot of new faces, that's really good thing to know. So today we are gonna be covering, so first, like everyone checked in. I want to double check that. Yeah, okay, awesome. So today we are gonna be covering a lot of stuff. We're gonna be starting building actually mini projects, but first we have all the way to the downside, like first of the announcements. Nicole, thank you. So we're gonna do a recap of Arduino, although we talked about it in the first orientation. We're gonna go over it a little bit, so we are all on the same page. So we are gonna start with an intro to electronics within Arduino using a breadboard. Although we touched a little bit about what a breadboard is and the orientation and how components work. So today is the day that we're gonna delve more into, as promised. Definitely we're gonna start talking about Arduino IDE, which is, you're gonna see this, please download it if you haven't. So there we're gonna be doing all of our coding and assigning the behavior to all of hardware components. We're gonna be, well, understanding I/O, which stands for input and output components. You're gonna see that in many robot applications, we have some components that serve as input and others as output, and that's a very important distinction. And finally, we're gonna delving deeper into digital pins, digital signals, and also a special case of digital pins, which is PWM, that we're gonna see in some minutes. And well, finally, like here the goal today is to actually do a quick lecture because we need to know what we're gonna do, right? So if that makes sense. But the goal is to like get started quickly with the mini projects. I want you guys to get involved, ask questions. This is a place to make mistakes again. I want you guys to feel very comfortable about making mistakes and everything. So quick Arduino recap. So what is it? For those that weren't here in the orientation. So it's an open source electronics platform. It's technically, although it's also called a microcontroller, it's more than that. It's an electronics board, as you can see in the image, and probably you will see in your kits that I see that already handed out to you, which is great. So it's an open source electronics platform. So there we're gonna be doing all our connections, and it's gonna be in charge of having the software inside the microcontroller, and it's going to be in charge of, manipulating all the hardware components that we're gonna be coding for that as well. So if you haven't downloaded Arduino IDE, please do it. There you have the link, and also if you want, you can visit the Notion page. There you have everything that you need for today. So first topic, very important. So before actually getting started with Arduino itself, so we need to understand some basic things about electronics. It's very important to get started with. And we are going to talk specifically about 3 key concepts that is widely used in robotics, but especially for Arduino this time. So we have volts, amps, and resistance, which technically they are like units of measure in electricity. And if we read the definition of electricity, it's basically, we define it as the movement of electron through a conductor. That's simple. The voltage, in this case, is going to be the amount of force that the energy has, right? So this combined with the current of the energy that flows through the wires. Those are measured in amps, or in smaller units of measure, they're milliamps that we're going to see after. And also we have very important resistance, and keep an eye on this because we're going to be doing some calculations that we need actually there. Very important to protect the components because as we might know, so there are no like power sources or batteries for all components, like suitable for all components. And sometimes there are like generic or like suitable batteries for a component, but it's still not enough. Like we need sometimes to get rid of some energy, because if not, we're gonna fry the component. So that's a very important thing, and it's measured in ohms. And if you want to look at it as an analogy, so we could say that voltage in a river, let's say in a river, so the force that the water flows is the voltage. The current measured in amps is basically the amount of water that is flowing through the river. And resistance, I don't know, guys, it's up to you if you want to build a bridge or something. But yeah, what's going on? Oh, okay. So continuing on this, very important, Ohm's law. We're going to do some quick calculations after this, but it's very important for you guys to follow this model that is widely used in electronics. It's very important if you want to delve more into hardware. This is going to definitely be your base case for all scenarios. As you can see, we have a whole bunch of formulas, which is basically the same one, but it's different, like in different orders of the equation. But if you want to calculate, for example, the resistance, which is the one that we're going to be using the most, is calculated by the voltage divided by the current measured in amperes. So we're going to have a voltage divided by amps. We're going to have something measured in ohms, which is a resistance that we need for a component in order not to fry it. So in this case, we're going to delve deeper into using the Ohm's law applied to Arduino in this case. So the question is, how do we calculate the resistance for a component in Arduino? So we must take into account three things for all components. This is common to every component that we're going to be using specifically for Arduino. But again, when you go to a real world, you're going to see that the robots use different microcontrollers that are not Arduino. They are like probably manufactured by some private companies that we need to understand before actually delving deeper into it. But in this case, we're going to know that the Arduino Lego Uno, which is our board that we're going to be using, at least for the component that we're going to be using, emits always 5 volts. This is very important to take into account. Please write it down somewhere. If not, you have it in your Notions page. The PowerPoint is there as well. The second thing is we need to know the actual energy current that the specific component needs. So as I said before, like different components have different specs. So we need to look them up and make sure and double check, please, like if you are applying the right force, the right current, the right voltage, and everything. And if you have any doubt about it, please ask, because if not, we might fry something and we don't want to. And lastly, but not least, we need to know the voltage that the component needs in order to power, right, to turn on. And if we follow this formula, so this is applied Ohm's law, right, in Arduino. As you saw before, for example, here we have voltage is equal to, resistance is equal to voltage divided by amps, divided by I, which is the current. We have in this case that the resistance in this case is going to be on the left side in the numerator. We have 5 volts, which is the energy source that I told you guys that it was 5 volts. That is a fixed amount of voltage that we know for sure that the Arduino is going to emit. Don't worry, it's not going to kill anybody. So we need it's going to be no less and no more than 5 volts. And that's subtracted by the voltage of the component specifically. So that's when we are building circuits, it's up to you to look up for the specifications on the specific component that we're going to use. So that's it on the numerator, and that's divided the current of the component, which is also, you need to look it up for the specific component. Can anyone, because we are going to be using LEDs if you want, can anyone look up what is the voltage and the amps that is needed for an Arduino in LED? And we're going to do the exercise. If you found it, let me know. How much? 5 volts? No, but the LED. How much? An LED. 2 volts? Yes. Nice. Yeah. You shouldn't count. Man. This is an expert in the field. This guy's an expert, man. So, could anyone find it? 2. And what about the amps, the current that we need for the Arduino? $20 milliamps. Let me know if you found it. Could you? How much? 20 milliamps, yeah, that's accurate. So, as I said before, for every single component, you have to look up the specific information about every component. And for example, here we're going to do the exercise. So how do you calculate resistance needed for an LED? So again, the Arduino, we know it's going to meet a fixed rate of 5 volts. The electricity approximately, because these are approximate numbers, and actually you're gonna find out that different LEDs use different energy, right? So it might happen that the red LED uses less energy than the blue LED. It sounds crazy, but it's like that. But it's an approximated amount, and we want to make sure that for this kind of projects, so there are some standardized values that we're going to be using, and you don't need to, because we are going to drive crazy everyone here if you had to find for every single component. But there's a standard, you're going to see. It gives us 5 volts minus, as some people say here, 2 volts that is required to power up one LED, divided by the amps that is needed to power up is 20 milliamps or 20 amps, 20 milliamps or 0.020 amps, and that gives us 150 ohms. My question is, let's see if anyone can take a guess. Why then it's a standardized way of using, why people use 220 ohms for an LED if the result here is 150? We're gonna find it later why, but can anyone take a guess why? Just in case is a good answer. Anyone else? No one? Okay, so when we calculate the resistance, of course it's going to be an approximate number, right? Because it's not like very strictly the way that the instructions, how the instructions are written. So in this case, 150 ohms is the amount, let's say the most ideal amount of resistance that we need for an LED in order to power up to its brightest level. But we need to find, if we don't have, for example, because it's very difficult to find like a precise 150 ohms resistance. So we are going to find the closest one to 150 above, right? Never below, because we might fry the component. So you're going to see afterwards that we're going to be using a 220 resistance, which is the closest one to 150. So yeah, that's basically. So definitely, what happens if we manipulate electronics while connected to the energy source? Knowing that the robot emits 100 volts, the electricity current the robot needs is 100 amperes, and the energy source is on. What's going to happen? You're not going to be alive to tell your friends what happened, basically. So for the real world scenario, I mean, this is like too much to exaggerate for an Arduino. Don't worry, because the Arduino is designed for beginner-friendly use, and like the amount of volts and amperes that it has is not harmful at all. But when going to the real world scenario where you need to actually deal with real circuits, with like more complex circuits, right? You need to make sure that the energy source is always turned off. Although there are like some security systems that shut down the energy in case something goes wrong, it's always a good practice to, work safely without the energy source on, definitely. So what we came for, let's start using Arduino. So first, we need to understand quickly how the Arduino hardware works and input or output components, as I said in the agenda. So they're here. They have a whole bunch of annotations, but we're gonna be using here the USB connector, which is the one that you need to plug into your computers, the Arduinos. So keep an eye on that. The microcontroller definitely is something that we're gonna use, but we're not gonna delve deeper into it. The analog pins, that's for the next workshop. And today we're gonna focus on the digital pins, which are, you can see that is from 2 to 13, including, right? So definitely that. And which is very important to know, guys, about the components. It's very important for a robot to communicate with the environment, right? And we have different types of components. We have components that are used to read data, to data retrieval. Those are called input components. And also components that we need to actually do something, right? Those are called output components. That's the first distinction within the components. And also something that we're gonna be distinguishing in Arduino is whether you're gonna be using digital signals or analog signals as well. And now we're gonna, for the analogs next workshop, but definitely we're gonna delve deeper into digital pins and digital signals. As you can see, as I said before, so from 2 to 13 is the digital pins. It's the little tiny holes you can see. Like, let's see if I can put this on. This is new to me, guys. Sorry. Let's see. Oh wait, there you go. So if I don't shake, zoom in or zoom out?
It's like there's like a wheel.
Oh really? Oh,
So you don't have to do that.
you saved my life. Oh, nice. There you go. Thank you, man. Appreciate it. There you go. Okay, that's fancy. Okay. As you can see, so we have this from 2 to 13 all the way that. So we're gonna be using, for today, those pins, and you have to keep track of them because definitely gonna be very useful for us and for you to know in the future. Definitely the digital pins, they have a very specific use, which, oh, it's not the PowerPoint here right now. Let me see. Wait. But yeah, so the digital pins, as I said, so a digital signal we're gonna be using, it's very important stuff. So it's binary signaling because in Arduino, at least I'm gonna do like a comparison because we have to always like do a parallelism between what's going on in the hardware and what's going on in the software for you guys to understand well what is going on. But in the Arduino IDE, you're gonna see that we are gonna be reading and writing, which means input and output for the digital pins is gonna be either zeros or one. And in the IDE, you're gonna see that there is a keyword variable that is already built in the Arduino IDE, which is low, which stands for 0, and high stands for 1. And what's going on in the electricity part inside the Arduino is like when you are writing or reading zeros, it's basically 0 volts. We don't have anything, we don't have signals. And if we are reading or writing ones, then we are going to power the full 5 volts. So it's either 0 or 5 volts. There's no middle point, at least for now. But in the future, you're gonna see that, so not in the future, I mean in some minutes, not very far away, you're gonna see that we can actually find, like, power up some pins. Yes, question? What, sorry? Oh, really? Yeah, please. So any questions up to here, guys? I know it's a lot of info. I don't want you to get overwhelmed, but we're gonna... Yes.
Is it actually zero?
What?
Is it actually zero when you're on the hardware side?
Hopefully, yes.
Hopefully yes.
I guess, yes. No, yeah, it's 0. It's 0 volts or 5 volts, yeah.
Like the hardware, so if you put a multimeter to the...
I mean, it could be like due to a misfunction in the Arduino, might read some values, but it's almost 0, yeah. So yeah, enough to read the signals. Yeah, that's a good question. Any questions, guys, up to here? I know it's a lot, but if you feel lost or something, it's the time to ask. Okay, great. So, but don't worry because I tried to put, although it's complex stuff, everything is there? Okay. Although it's complex stuff, trust me that this is like the most that I could reduce it for the lecture, but we're gonna delve deeper into the concept as we move on to the projects, and I guess, yeah. You don't have an Arduino? Wait. Okay, fine. Okay.
Before we get started on the projects, does everyone have their kits with everything in it? You should have at least the, oh, you don't? I can maybe get you one. You should have at least the Arduino, the little blue cable to connect it. You guys should have your LEDs, your little pack of resistors, and then the PWM, but we'll get to there when we get to there. Everyone should be paired up with someone who has a USB port on their computer. Yeah? Okay, cool. Yeah, sure.
Okay, so, well, moving on with the digital pins. I don't know if I'm going to use the mic because my voice is starting to. Digital pins. Wait, let me see. Okay, we good?
Yeah, go.
Yeah? Okay, okay. So any questions up to here? Again, just to check we are on the same page. Yeah? Ready to move on? Right, great. So, and well, lastly, where to connect the components that we're going to be using digital signals. Those are called the digital pins, the black holes that I showed there. Not the black holes from space, but from there in the Arduino. And it's going to be, we're going to be using from 2 to 13. Actually, 13, we are not going to use it. How many of you remember the LED, the built-in LED that we made blink? Remember, guys, that we connect? That I didn't know what number was behind the scenes. So yeah, the LED built-in was 13. I Googled it. So that pin is in charge of controlling the little built-in LED that we made blink in the orientation. For those that were here, it was basically this little thing here, right? So yeah, great. All right, so everyone's ready to start? Yeah? Okay.
Let them know where they can find everything.
Yeah, that's true. All right, so now we're going to start with a whole bunch of mini projects that we're going to start building, like from simple stuff to more complex stuff, try to build up on what we learn, right? So if you want to, actually, you need to go to the Notions, to the Explore Hub that we provided for you guys. And you can see that we have a Project 1 dropdown. Let me see if I can show it to you. So everyone could get here to the Explore Hub. It's go.fiu.edu/init. No, Explore Hub.
Okay, guys, if you go to go.fiu.edu/explorehub, how are they going to find your Notion? No.
I don't.
And then under hardware, there's going to be a Notion that says Arduino Fundamentals, and you guys should see this Notion page, and you can see all the projects. Maybe refresh it, because I updated everything.
So everyone could find the Explore Hub. You need help finding it? ¿Encontraste? Yes? Okay. Did you guys, could you guys find it? Yeah? Great. I like it.
I got you, bro.
Thank you. Hi, did you check in? No? Nicole, can you check her in? Possible? I got you. Jorge's over there. If you want, you can sit there. I mean, if there's one space.
Do you have a USB port in your computer?
No, you have, yes, you have.
Our board, breadboard came with this in it, and I've been trying to remove it, but I don't know.
Oh
if
my
it's gonna
gosh,
work,
this
the
is
weather or not.
this is wild, man. But
What's on it?
oh, ooh,
Resistor?
yeah, a leg. There you go.
Oh.
Now it's clean. No, I mean, it's not gonna happen in the future. I know this is just like, way down, but kind of you need to press the button. Yeah, so now, I mean, it's fine. But let me check the LED. Can you put the right leg? Long leg is right. Okay, let me actually say to the So guys, when wiring this up, make sure that the LED, the long leg, hits the resistor with the positive charge, which is connected as like the resistor is kind of a bridge between the connection from pin 11, as you can see, and the right leg. Sorry, the right leg is the long leg of the LED, and the short leg is gonna be our negative charge pole, which is connected to ground. Here too. Yeah. Yeah. And guys, there's a convention in electronics that if you want to follow and start doing good practices for the industry, like general when you're working with negative charge poles or energy, you tend to use black wires, and the positive you can use white, red or green. So that's a good thing to know. But you're gonna work with anything basically. But if you want to start, getting used to the industry, that's a good thing to know. And make sure, I mean, I explained this in the orientation, and I'm gonna repeat it just in case, that when wiring in the breadboard, as you can see, when you connect to one of the little holes in the breadboard, you're gonna fit the entire column, but up to the separation in the middle, like this one, right? So make sure that the LED and everything is on the right column that you wanna fit, because we're gonna run into problems if not. Huh? Just Oh, oh wait. I just told them. Thank you. Oh, guys, I forgot to tell you that the resistor we're gonna be using is a 220, as we saw in the exercise. So you can see the color pattern. It should be the same as in this diagram. So make sure you're using the right resistor, because if not, it's not gonna work. What's going on?
Hello, Professor.
Hello, how are you? ¿Cómo va? ¿Qué me ibas a preguntar? What did you want? ¿Qué me ibas a preguntar?
Nothing. Thank you very much
No,
for
very
your
good.
assistance.
What was it? Nothing? All right. I'm glad to help. How are those circuits going? Well, I'm gonna give you guys a couple more minutes. If you need help, just call me.
Absolutely. And you want to turn it off, and you just
Yes.
with this one.
It's very difficult to
Yeah,
tell. I
it
know,
was-
I
I
know.
was like-
Let me see, because it's even myself, I'm kind of, it's like, no, it's not that one.
It's not this.
It should, you should see like a 220 here.
Okay.
So literally it says like this, 220.
Okay. Perfect.
Let me know if anything. Oh wow. Tend to. Huh?
Then which one is it? Like the one that's like, is it matter which way?
No, because
Oh.
it's bipolar. No, no, no.
Oh, okay.
So you don't. It's actually because you could also connect it to the ground, which is the negative. But as it is bipolar, it doesn't matter what you do. But generally, you tend to do it with the positive thing. So, for example, here the positive and the positive leg. So, oh my God, this is
Yeah, I was gonna ask actually, because why is this specifically on 7 instead of 6? Like.
No, no, no. I mean, that's just I chose those
Oh, okay. Good.
columns. You can use any column of the breadboard, but just make sure that whatever component you touch is in the same column, sort of.
Okay.
I was gonna ask the same. Why was on the red one was on the D,
On the D,
the rows?
let me see. Come if you want, like the D.
Yeah.
No, I mean that's because
And
just
also the resistor on the B.
it's not a matter of rows, but you need to focus on the row, on the columns instead. So, for example, here we're connecting the 11 to here, right? Yeah. So, for example, the ground is connecting here to column 6, and it's gonna be the entire column. The negative column of the left. The same column, exactly. 11 goes there, it goes here. But it could have been to the right leg of the LED. It's like the bridge. You see the pattern? Like here, resist, and goes with left and exactly. We have to move on to the code first. Or first the reconnect everyone. Because I've been helping other people there, but don't worry.
Don't worry, I'll help you. You focus on getting your connection.
Yeah,
and I would
let me
show them
see.
really quick.
Yeah. Project 1. So this is gonna be. How's it going, bro? Come on.
¿Cómo sabes que es rojo, naranja y negro si no ven ningún rojo, naranja?
Porque tenemos el 220 ohm. Acuérdate que,
¿Ah, es
fíjate que acá
220?
necesitamos 220 y buscas el 220. Alright guys, so everyone could get the circuits done. Guys, everyone. Yeah, okay, so we're gonna move on to the software part. Alright. So as you can see in your Explore Hub, you got the file name project 1. You can open it with your Arduino IDE. And basically you need to code where it says to do, and you're gonna see, for example, on the right, we have the structure of the Arduino IDE, which is very important to get started. So if you guys can pay attention to this particular image. So for example, on top of the file, we got, you can see int let pin equals 11, semicolon. Remember that we are using the Arduino programming language, but it's built on top of C++. So we're gonna be using C++ syntax. We need to be very careful with semicolons and be specific to the types of the variables that we're gonna be declaring. In this case, it's gonna be an integer, well, of type int, of course. Let pin the name of the variable equals and the value to store it, right, to save it in memory. That's the first thing. And regarding the structure of the Arduino IDE files or sketches, which is the name of the files that we're gonna be uploading, on top of the file, you always declare all your variables there. Then you can see that we have a function that in C++ for Java programmers might be familiar, but we define a void function, which is basically do not return anything, right? Doesn't return anything, it just does some task. For example, in Java, for example, if you took programming 1 or programming 2, you could see that the void generally is for variables, right? Just printing out something to the console. But in this case, we can call functions that are built in Arduino. It's object-oriented, so we don't need to worry about anything else rather than that for now. But in the void setup, so it doesn't return anything, this is very important function, because although you can master your loop, right, have the best application ever in robotics, if you don't set up your components well in the setup function, nothing is gonna work. So you need to make sure that we use the pin mode, and the first argument, as you can see in the PowerPoint, is type of int. So I didn't specify it there, I forgot to add. But it's gonna be a type of int, it's gonna be an integer that we're gonna pass as the first argument, which is the name, the number of the pin. In this case, as we saw in the diagram before, it was 11. So everyone make sure that we have the same pin. because if not, it's not going to work. And we have pin mode. We're going to be using the LED pin, and it's a good practice though to store those variables before, because imagine when we will have like 3 LEDs, we don't want to always call like numbers, which is the pins themselves, but instead we want to use the name of the variable. So when we develop larger and more complex applications, we can keep track of what we are doing with the names of the variables. So that's very important to note. And in the pin mode, so the first argument is the pin, and the second argument is whether we are going to be using, as we discussed before, an input or output component. So as the LED is basically going to turn on, it's an output component, right? And it's the only component that we have for now, so it's just one line of code, but it's very important. And then basically where all the logics comes into play, we have the void loop, which is always running for you, because imagine if it wasn't running all the time, it does all those 17 lines of code, and then the robot would shut down. So Arduino makes sure with the void loop that the robot is always turned on, right? And it's kind of saying, it's the equivalent for those that have programming skills, saying that it's a while true or while forever, basically. So it's not gonna stop. And it's gonna repeat all over again, and again. So as you can see there, so I put you the comments to do, and you can use, you need to figure out what function you need to use, but you're gonna be using the digital write that you can see. That it takes also a pin as the first argument, and the second argument or parameter is gonna be either high or low. Remember guys, that for the digital signals, we had either 1 or 0 for both read and write. In this case, it's write, it's an output component. We're going to be passing to turn on what we're going to be passing there as a second argument to turn on the LED. High. So it's going to be digital write, parentheses, the name of our variable, that's why we define it, LED pin, comma, high, and parentheses, semicolon. I'm going to write it afterwards, but I want you guys to understand it, what's going on. And then I put there what the delay function does, which is also a built-in function. So we're going to be using, basically, we're going to borrow stuff from the company that provided for us in Arduino IDE. And the delay function is basically freezing the execution time, the runtime, right? So in that sense, because what would happen if we don't have the delay function? It's just high and low without delay. What's going to happen? Anyone? What will happen, guys, if we don't have like any pause between, oh my God, I must break this, between the high and the low, like turning on and turning off? Any guess? Yes.
It would just stay at whatever the previous state that was defined at.
Exactly. So it's going to be basically all like turned off all the time, because C++ particularly runs so fast, which is built for this type of systems. And you're going to see if you delve into embedded systems, which is programming in this type of boards, right? It's going to be like, it's called low latency code, because you need to be super quick. And Arduino is built for this particularly. So if we say, okay, digital write, high, and then instantly the second line is going to be low, then it's going to be high, low, high, low, high, low, and we don't have anything basically. And it's going to be as if it was turned on. So we want to make sure that we use the delay function, which takes milliseconds, right? So if we put, so 1 second is 1,000 milliseconds. So if we say turn on, wait 1 second, we're going to see that it turns on, turn off, and then wait 1 second again before turning on back again. So I'm going to show you what it would look like right now. It was .com, right?
Yeah.
So my Arduino is kind of flying because I cannot put, it's kind of a mess, but I cannot put it like, it should be that pace, guys. Could everyone get it? If not, I can start coding along with you, and you tell me what we can do. There you go, at least. So could everyone make it blink? Could you get the code? Yeah? Awesome. So what's going on, as I said before, you're declaring the variable let pin, saying what we want to do. Output is an output component. And then we're going to, oh, we have one hand. Where? You? Okay, what's going on? Oh, you have an error? Let's see. This can happen, guys. What's going on?
Okay.
Why though? Oh, you cannot find why. Really? Wait, why you don't have the navigation bar?
Jorge, why don't you have the navigation bar?
Cannot find the system. So you have everything connected, right? Yeah. It blinked?
Yeah. Se
No,
encendió y
no.
se apagó.
¿Cuál este?
¿El rojo?
No way.
Let's go again. I swear. Red.
Oh, because it's not working very well, your USB
Apaga
port.
the USB.
Cámbialo de yo.
It might not be your port, it might be the...
Es esto. It's not the port, it's the thing.
It's a thing. Let me try to get you another one. Any issues, guys? We could make it blink. Yeah, I see the green LED. Good. Let me see if I can get you one. Try it.
¿En cuál iba?
Tiene que ir ahí, tipo ahí, literal ahí.
En el 11, ¿verdad?
Ese es el 10 donde lo estás poniendo, creo. Ah, no, es el 11.
Ay, para subirlo. Oh. No, because it cannot find the board.
¿Esto?
Yeah. Nicole, can you have here this table?
Why?
Because I want to move. Why is off? What?
What project are we on, the second one?
Oh, wait. No, first.
Still? Oh, Lord.
Yeah, we're helping people there. All right. I want to wait for them to... Oh, you need help. Everyone here is fine? Yeah? Thank you. I mean, awesome. Yes, what's going on? Okay. She's gonna help. Because if not... All right, so moving on to the next mini project. So let me see. Oh, wait. Yeah. So let me use the microphone. So here we have our second project that you can find also in Explorer Hub. You can download the code there, but it's very similar to what you already have. And in this case, I want you guys to try to add 2 more blinking patterns. And instead of using 1 second or 1,000 milliseconds. I want the pattern to be, I would like the pattern to be like 500 milliseconds and 250 respectively. So if you guys can do that, and then if you need help or run into some issues, but I want you to get started with the digital write function, like I need you guys to understand it so we can move on with more complex stuff before. It's the same circuit, by the way. It's just adding lines of code below. Because people need help, so I try to.
Yeah, sorry, my mom.
No, yeah, don't worry. That's why. Because I saw no one was here, so.
The problem that they had, in case you see that problem again, is
I don't know why they have that problem.
the serial port wasn't
port.
the right one. So if you go to tools,
Oh,
Serial
he
ports?
didn't choose the. Okay,
Yes.
yeah, good catch.
yeah, most people I think it does it automatically, but
Some
you might have connected to a different.
I don't have. No, because I cannot pull this. Or yes.
No, not that. Move you.
No, because I have this, the laptop. That's why I cannot move this. I thought it was like,
That's fine.
it's like fixed.
Yeah. Did you tell them that it's the same connection? Like it's the same.
Yeah, I
setup?
told them. Yeah. It's just writing some lines of code.
Yeah, they seem to be connecting it really quickly. So like most people
Yeah,
I
yeah.
saw were already even moving on.
Yeah,
to
I
the
know,
port
I know.
themselves, which is
It's
cool.
fine. Oh yeah. Delay, digital write. So. I thought I was showing the code like. Yeah. I'm so confused about all the sources here. My God.
Don't worry.
Yeah. So this should work like this. Delay. Oh my God.
We were
Working?
wondering.
Nice.
No, we need to put it like in this direction or this.
Wait, another LED. Not anything. Like within the code, not components. No. Like, just in case I confuse you guys, it's just like one LED and it's just like even more like patterns per second. It's just one LED, one component. And well, let me like that. Try to make it. everyone could get the circuit and the code running. Yeah, with the patterns and everything. Okay. For the software enthusiasts, is there any way we can clean up this code? Over and over the play, to the right. Let's start playing with the C++. What? Randomizer, it could be, but that introduces something else, which is random. Who said for loop? For loop is one. What else we could use? While loop as well, but think of another if else. And we have one more actually. To perform. Thank you. What? Switch as well, but in this case we're going to be using an if else. We just need one more like element of programming. What could be? To write tasks. Automate tasks. What could be? What? No. Functions? No? Yeah, you should have said. You should have said. You should have said. Need to be more confident. Trust in yourself. Well, so yeah, so if you open the project to remaster, I couldn't think of another name, honestly. But it's doing the same, but in much cleaner way. So you can open up and I can drive you through the code. So what is going on, and for those that don't have programming skills, we can see what is going on in the code as well. So let me open up. So did you guys open the project to remaster? Could you upload it to the Arduino? Let me know if you could upload the code. Skipping ahead. Yeah. So everyone is ahead of this project already? Yeah? Okay. Which project? Because I have different paces here. Which one? To remaster, yeah. So we are in to remaster. Everyone is in to remaster? Yes? So you can see that if you upload that code, it should blink the same way. But let's go over the code a little bit. So it's the same in the, we define the variable, let pin, the void setup. So everyone is lost in terms of programming. Is everyone lost? What's going on there? In general, but anything that, any doubt, any specific doubt? Okay. Anyone like feels not confident with the code? Everyone, wow, we have good programmers here. Okay, that's cool. So you can see in the for loop, in the void loop, so inside of the function that works as a loop, we have an inner loop, so you don't need to worry about it, but basically over and over it's going to repeat the for loop. So it's going to initialize pattern 1 up until pattern 3. So we define int pattern equals 1 for the first part of the for loop, semicolon the condition. So we want to run the for loop until when, basically, which is less or equal than 3. And after the for loop, we want the pattern, the variable that we initialize for the loop, to increment by 1. So the Java programmers should be following me very closely. But yeah, so you can see that, for example, we're going to have 3 iterations, one with pattern 1, pattern 2, and pattern 3. Because in pattern 4, what's going to happen?
It's going to start over again.
But where? It's going to start where? At 1, yes, sir. That's good. Okay, so we're going to be doing digital write. So basically, that's what we're going to do. Let's see that we just call for, instead of 6 digital writes, we replace it by 2. So we're saying, calling the digital write, turn on the LED, and then we are calling a function that we built. This is not built in, this is something that we wrote. And it's called delay pattern, and it takes an int as pattern, as a parameter, which is pattern, right? So basically we are gonna be sending from 1 to 3 in all 3 iterations, right? It's gonna be 1 and then 2 and then 3. And then again 1, 2, 3 and all over and over again. So it's gonna process it, the function. It's gonna say, okay, what do we have here? What pattern? Is 1 delayed by 1 second? If it's 2, 500 milliseconds. If it's 3, it's gonna be 0.25 seconds. And that's how we basically clean up everything and start playing a little bit with the C++ code. So, any questions here in this code? Any questions, guys, for this code?
That's actually much cooler. So.
Clear? Yeah? Okay, great. All right, so let's move on to the next project. So now, as my friend said, we're going to introduce some random variables here to start making it more dynamic instead of just static. But I want you guys to understand first what is a digital write, what are the arguments, 0, 1, what's going on. So now we're going to introduce random, and I want you guys to use actually to start building up from the previous one. You could tell probably the pattern that we're building from the previous mini project. So here is basically just one line of code. Where can we introduce randomness in this code? You can see, we can read the comments and you should be able to find where that needs to be. What do you guys think? Which loop? The for loop, but where? Tell me the line. Which line? Which line of code? Which one? 13. No. 13 is calling actually the function that is going to introduce randomness. What? Line 10.
Basically, at the end of the loop, it says I plus plus. So basically, you can do like change the value of I to a random value in page 3.
That's a good one, but in this case, as you can see the difference from the previous one, I changed the variable but on purpose, the variable name. We are not going to be using the variable from the for loop, right, as a processing pattern, right, because remember that before we're going to actually, it's still there that if pattern equals 1, if pattern equals 2. So we are not going to pass that I as an argument because that's not what we want. We're going to introduce randomness. So pick a random value. So here we changed pattern for I, which is just going to be basically our variable that we are not going to actually be using it just to say, okay, iterate n numbers of time. In this case, it's going to be 1 to 3, including 3. So you're going to call the digital write to turn it on. The delay random pattern, you can tell that there are no arguments there. Why? Don't ask for what? For arguments? Yes, that's a good one. But if you can see in line 23, what it says, code, literally it says code to implement random pattern, and a hint to call the random function, which you can see actually in the PowerPoint on the right. I always include all the functions I'm going to use, so you don't get lost in terms of the function we're going to use. So in this case, we're going to be using a random function, which is the same as digital write or something, or another function that is built in on Arduino. Arduino provided us with a random function that we don't need to code. And you pass 2 arguments, from or to, and including both from or to. So it's going to basically take one random value. If we pass, for example, random parentheses 1, 3 is going to be with equal probability 1, 2, or 3. So that should look like more, random in terms of the pattern, and you should tell it in the blinking. Let me know if you could code it, or you need help, or you want me to actually let me code it for you. So as you can see here, as we said, code to implement here. So we're gonna do this, and we're gonna say, so pattern, it should be an integer, right? It's gonna be 1, 2, or 3, type int. So does anyone want to tell me how do I define an int variable called pattern here? Anyone? How do we declare a variable type int called pattern? What? I follow you, man. Int? Pattern? Equals, and now what? The magic, that's it, random. What values should I pass? I think random includes like. It's exclusive. All right, so it's gonna be 4. Thank you for pointing that out. So yeah, it's in the exclusive range. So 1 to 4, which is gonna give 3, right? Don't forget the semicolon. It's gonna break everything. So now if you upload this, it should work, hopefully. Could everyone copy this part of the code where we introduce the randomness? Yep. All the tables? You can tell we cannot predict the pattern. You see that? Yeah, so we start building basically dynamic applications, and when we jump onto the input and output, actually we're going to start, instead of just giving instructions to output components, we're going to start reading data and do something with that. So you're going to see in the next projects. So let's move on with the fourth. Starting to... What? How's it going here? I'm dying. No, my voice is, I'm avoiding coughing so hard. Oh my gosh. So guys, let's move on to project 4. Everyone is on the same page. It's more like we have people that fell behind. We went like all the way to project 6. Let me know. What is going on in those tables?
Call everyone out.
Project 4, so we are on the same page? Everyone on the same page? Ah, that's awesome. Okay. All right. Okay, so this is a new concept that I actually need you to introduce before. I'm not going to use the mic. I don't like using it, but, maybe I should have. I should. So we have pulse width modulation, which is PWM that you can actually see in your boards. That is, there are like little letters there that it says really like a symbol PWM channels. Those are like labeled with a specific use because they are part of their specific use of the digital pins, right? But they can do something else, like they can actually do something different than the other. Like for example, here you can see 3, 5, 6, 9, 10, and 11 have PWM capabilities, which is, oh wow, wait, it turned off. Why? Desktop? Oh, I wasn't showing the. Wait. Desktop? Oh, there you go. My bad, guys. So now, yes. So it wasn't the image before, right? No. Yeah. Sorry for that. So as you can see, like we have 6 PWM channels that are also digital pins, but they have specific functionality. And what it has is that the output, right? So when using digital signals for output components with PWM signals, which stands for pulse width modulation, instead of just passing either 0 or 5, we can actually pass something within that range. So this will allow us, for example, to change the brightness of the LED. It's not like fully bright or fully turn off. So you will see that it's in terms of the Arduino IDE, so it's going to cover from 0 to 255 inclusive. That's the number that Arduino put. There is something going on behind the scenes, but when processing PWM signals for input and output, it's actually from 0 to 255. But remember that the digital signals is just for this 0 to 255 is only for output, not input. And input, we're going to see like in the next workshop. We're going to be using, for example, ultrasonic sensors and other stuff that use analog pins, which is a whole other animal, basically. But for now, this is it. So in electricity, so it's translated between 0 and 5 volts. So it could be, anyone can take a guess. What if we want to pass the half of 255, so it should be like near 127 in the Arduino IDE, how many volts it would be translated into electricity terms, so to speak? Exactly. So we're going to have half of the voltage, and you can see that it's going to be half bright than the full power. So here we will use analog write. Yeah, so now we introduce another function, which is analog write, which is different from digital write. Although it's still a digital pin, I don't want you guys to get confused, but we can use the analog write takes the pin, the first pin as a parameter, like the pin number as the first parameter, and then the value, which should be from 0 to 255, basically. But it's still used in a digital pin, so you shouldn't get confused with that, because we're going to see that the analog input and output are something else. And they work similar for the output, but not for the input. So let's start with the project 4. So we're going to start changing the brightness of our LED. We don't need to wire anything. It's just like keep playing with the code. So actually keep using, because what pin are we using? 11? Okay, yeah. So here I put 9, but you can keep it to 11. So it should be int LED pin equals 11, right? The setup, we're saying that it's still. So although it's a PWM in the Arduino IDE, like in the setup, it didn't change anything. It's just a hardware capability that we're going to be using. And here, I want you guys to implement the analog write in this case. So you can change the brightness, and you can actually download the code first in the Explore Hub. But the instructions are in the comments, and you should be able to handle the brightness correctly. So if you guys have any questions on PWM or something, how it works.
Do we have to change the connection here?
No. Same connection, guys, just in case. Did you guys get how PWM works? Yep, clear? Just want to make sure that everyone understood PWM signals? Yeah? Okay. Actually, PWM digital signals? Yeah. And remember that on the right you have all the functions that you should use. No digital write, this time analog write. Because if you try passing 3 in the digital write, it's gonna run into an error. So you should use definitely the analog write, which takes, oh wait, I put higher low, which is not that. 0, 255, there you go. Anything from 0 to 255. And still the delay function and everything. There we have a very short delay, but because we want to like give a fade kind of effect, so to make it cleaner. Any questions, guys? To hear? Good? Okay. You guys need help? No? Awesome. Here, guys? This table? All good? Great. You, my friend? All good? That table? So? Well, you have an expert next to you. How is it going? Give me feedback. Good? Great. There, guys? Thank you. Great. You're done? You guys are done? Yep. Look at you. Here, guys, all good? Understood everything? Clear? You need help with anything? No? Fine? Okay. Let me know if anything. Here, guys, how is it going? I know it's a lot of stuff, but trying to
So we have an
do it.
error.
Let's see.
But I think it's, I'm not sure if it's like a copy and paste thing.
Wait. You downloaded the right file, right? Actually, oh, you know why? Because each file, you need to open like a different project. You don't need to copy. It's just for you to open and then doing it there. Because I think you are mixing something from the previous project to this one. You know what I mean?
Pretty sure we deleted everything.
Really? No way it's on my end.
Try it again. Wait.
No way it's my fault again. Let's see.
If you want, you can remove everything and then
Oh
try
my
it
gosh.
again. Right.
Delay random pattern.
Oh wait.
Oh
did you-
yes,
did
because
you-
here you see.
Oh.
Wait, this should be 11.
It's fine.
And then we should release
Yeah.
this. And then it should work. Oh, it's not working. This is something else. Let's see. Setup. What?
It's a.
Oh, yeah. But wait, because we might have.
That one goes with that one.
You touch it. You touch it. You touch it. I don't want to mess up.
You can leave and copy paste again.
Yeah. Hold on.
Ooh. Let me know. Let me know if anything. ¿Todo bien acá? Everything good? So good so far? You guys are cracking it, man. You guys are good. You guys are good.
Thanks to you.
No, thanks to me, bro. Guys, how is it going here?
¿Sabes leer código Morse?
Good?
¿Sabes leer código Morse?
No way. You are doing Morse code?
Espérate, es que cuando empieza el verde ya empieza a salir el amarillo.
El verde es de que ya va a empezar. El amarillo es la palabra y el rojo es
Ah, bueno.
término.
Ahí va. Ahí está el verde, a ver qué dice.
No, no tengo idea, viejo. I don't know Morse code. I don't.
Dice rojo.
Bro, but it's cool.
Experimentando un poco.
Yep.
What piece is that?
Oh, no, no, no. Actually, I put that picture. No way. Oh my God, guys.
just did all of it.
Wait, are we not supposed to do that?
No, no, no. Yes, yes, yes.
Oh my god.
But I mean, oh, that's the project 5?
Yeah.
Oh, you're moving on. Okay, no, it's fine. Yeah, you can. No, 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 no. No, no, no. It's fine. It's fine. Actually, you are going.
We're slaying the game.
It's better. Traffic lights. Yeah.
Is it a dials?
No, because actually we are not going to use that for that one. We're going to use it in the next one. I mean, it's this project, but ignore this. Like just the connections of the 3 LEDs.
Do we still connect this?
No, no, because actually, yeah, I wanted to cut, but I couldn't.
It's okay.
Sorry.
No, you're good.
All right. No, yeah, you guys are doing very well. So, what do we do? Like, it's 10 minutes, but I have like other projects, but
Do you want to try to do the last one?
like introduce the input
Um,
or the traffic light.
Because you have 5 and 6. Are
5
they
and 6.
both input?
No, 5 is output still, and
Then just do 5 and then
5?
introduce input next time.
For one of my workshops, I didn't have enough for the first workshop. I didn't have enough time to finish all the concepts. So what I did is I sort of left it as far as I could, and the second workshop I started very quick and finished the first one, and we'll jump into the second one. So don't feel bad if you can't finish.
okay. No, no, actually it's better because I was afraid of not having enough
Right.
materials.
Even better. Yeah.
No, because
it makes sense because all of these projects have been output based and that last one is input based.
no, because I see people like there are different like so many diverse spaces. Like
Yes. You know what I think the problem is? Not a problem. I mean, it's good, but we gave them all the code.
yeah,
So people were just kind of doing it on their own. So it's
Probably
hard
for
to
next time.
manage.
but it's still. I mean,
It's just hard for you to then have to go in and manage
Yeah, it's difficult.
the code. Maybe it would be better to just show them
yeah,
the code and have them copy it. Yeah.
yeah,
And then after the fact, we upload everything.
yeah. Okay. No, yeah. Well, I'm gonna explain like the last project, but it's still like it's like intensive. The last one.
Okay, so just
It's
do
fine.
the fifth
Yeah.
one.
Okay.
Do the fifth one and then it should take like 10 minutes and then be like, for next time, this is what we're gonna be doing.
Great. So I introduce the input in the next time.
Yeah, if you can give me, can you put back my notion? I want to
Yeah.
make sure that everyone filled out that form. Just one second.
Use the mic because everyone is.
Yeah, I'm gonna yell at them. Go up. Yeah. No, down. Go down. This is QR. Guys, really quick. Keep doing what you're doing. But if you guys walked in late after my presentation and you didn't get a chance to scan this QR code, please do so now because if you're part of the hardware cohort and you attend all 3 workshops and fill out this form plus an exit form, then you're gonna get some Q Explorer merch. This is really important for us to gauge how the program is working and see if it's really benefiting you guys and what we can do to improve it in the future. So, yeah.
Yes.
Other than that, keep doing your Arduino stuff.
So I present the. Yeah, I showed the last one. Yeah. Okay. Chanda.
No me funcionó el potenciómetro, así que le metí aquí.
Es que no te deberían haber puesto el potenciómetro. Es que me equivoqué la imagen.
Pero ¿tú crees que lo hicieron con el joystick?
No, está bien.
Está bien.
So guys, I know we are running out of time, but to close, I wanted to like try to do the most of this project. Like it was like this is a kind of checkpoint to see if all the output concepts, the digital signals, the PWM is, you understood it well. Because for next workshop, we're gonna start with input components, analog components, and we're gonna start actually building robots that interact with the environment with you. So I want you guys to fully understand what is going on, what we did today. So if you have any questions, please ask. But if not, you can start doing this traffic light with 3 LEDs. So you need to wire them right, you can copy the same the same diagram. Please ignore the potentiometer on the right. It's just a matter that I didn't find any picture that had 3 LEDs. But the potentiometer is for analog, so we're gonna be using it in the next workshop. But for now, I want you guys to connect the LEDs to 9, 10, and 11 pins, which all are PWM capable. Because you'll see now, when I show the code, let me see. So here you can download Project 5. This is the largest that we did so far. Don't get overwhelmed. We define the variables for, instead of just one, as we generally did, we're gonna have 3 variables, one for each pin, which corresponds one for each LED. And it's great if you can name them appropriately so you don't get confused with the hardware. And in the setup, I want you guys to do it. I didn't put anything, but you can, if you forgot how to set up the pins, you can look for the previous projects. But basically, you're gonna say what you're gonna be doing with the 3 pins in that part, the setup, the void setup. And then in the void loop, in the logic, you need to do basically the to-do, basically. Yeah, so it couldn't be more clear, but if you have any questions on the logic or something, I know I try to, in this case, there's no much guidance because I wanted you to see kind of evaluation of what you guys learned today and be aware of that to take it into account mostly for the next workshop. So if you guys can implement this code, that you can also download it in the Explore Hub before you go, and you would finish with basically with the traffic light project today. And if you see, we are mixing everything: PWM, digital, analog write, sorry. And again, the functions are on the right for digital and analog writes, respectively. I think they like this project because they're kind of, I see them engaged with that.
Everyone's really into it.
Yeah, that's a good thing. So tired.
Yeah, pobrecito.
Huh?
Pobrecito, you've
Stick
been napping.
around
Yeah.
for the meeting today.
No.
Nah, you don't have to.
I mean, if you
The
guys,
only person who needs to be there is Louis, guys. And you guys, no pintan nada.
no, but today I was so,
Yeah, but you're just friends.
I was feeling so sick. Like the Super Bowl, I was like
Yeah.
laid on the bed.
So many sick.
Yeah.
Super Bowl was
But
crazy.
I think
That shit was great. Fuck the Chiefs.
I would say something, but I don't see it. I don't want it.
I don't care about football. I just want to hang out with my friends.
How is it going so far? Good? Need help? One sec.
It's like the convention for current flow in this, because I know we're doing, like, let's say you have the LED here, you have the shorter one, which is a negative. Obviously, that goes to ground, but are we? Is the convention to go from ground? No, it starts like from the whatever pin, 5 volts, and it flows to ground, right?
Yeah. Generally, you plug in the resistor, like acts as a bridge between the positive charge and the negative charge. Sorry, the positive charge and the actual pin of the Arduino. But as the resistor is bipolar,
Right.
you could technically plug it in the ground. And
Right, but which is the convention for like flow of electricity, is it positive and negative? Like it starts at because it has to close the loop, right?
you close the loop, exactly.
You start at
Sorry.
your pin. No, it's okay. You start at the pin and you go to the negative, right? Or do you start at ground and go to that?
Yeah, exactly. You always look like first for the positive and then you close up with the negative.
You close at ground.
Exactly. Ground is always the last step.
Okay, sounds good.
I mean, if you're looking at the diagram, you can basically draw a circle. and the ground is going to be the last part. Like it's not clockwise, it's the other way around. ¿Cómo va esto? El último está picante, ¿eh?
¿Esto qué es?
Ahí
Hay que poner.
el ground.
Pero en cada uno.
Tipo, porque fíjate que en vez de usar... fíjate que acá están el 5 volts, no, esto no lo use. O sea, tenés que usar un ground, que puede ser este, al negativo. Y eso por ahora. Y le vas a... Porque con el negativo, si vos le pasas al negativo, te va a alimentar toda la fila de negativo.
Okay.
Y de ahí, en vez de hacer un ground para cada LED, puedes hacer 3 desde acá, desde la fila negativa, y conectarlo a cada LED. ¿Entendés? O sea, acá estás metiendo, ¿ves? O sea, acá, este cable negro, lo que hace es alimentar toda la fila. Y ves que acá salen, exacto, lo que salen los cablecitos negros para adentro, desde acá.
Ah, pero no tengo que poner unos nuevos.
No. O sea, sí, desde acá hasta acá. O sea, necesitas 3 cables y uno para... 4 en realidad. Uno para el principal y uno para cada LED. Sí, exacto.
Pero de los pequeños.
Sí. No, de nada, bro. Guys, I forgot to mention that in the diagram, like it looks a little bit different from the ones that we've been doing with each LED. Please, like, first ignore like the potentiometer on the right, like just the LED stuff. But you can see that there is one cable that is going all the way to the negative row, not column. You can see that? Like on the bottom right. That we have a ground from the Arduino to the negative row of the breadboard. On the bottom right, you can see it. Great. So that's going to basically be your ground channel, but for the entire row. And then, as you can tell, there is, for each LED, there is on the the shorter leg, there is one ground that is connected to the negative of that row. So I don't know if that makes sense. Like the ground is connected to the row, and then from the row, you connect to every single LED. So you don't need to plug it in with 5 grounds or 3 grounds of the Arduino. It's just one for the common row, and then from the row, you can feed to the other LEDs. So you would be using 4 ground wires. And then the resistance on the pins is the same as before. ¿Cómo va? ¿Bien?
Yo creo que estaría bueno que mencionaras por qué importa la dirección en la que pongas el LED.
Es que le había dicho al principio, no sé si lo van a...
Entonces no te escuché.
No, tranqui. Pero es verdad, ¿eh? Sí. So remember, the LEDs are one positive charge leg and one negative charge. Make sure the the longer leg is connected with the positive, which in this case is with the resistor and the pin, with the resistor acting as a bridge. No, it's fine. It's just because I'm talking too much. No, but I like it because people are engaged. You know?
But if you want, I can yell for you.
No.
I got a strong voice for what, bro?
If you need to leave, go. I just want to stay with the people that...
People meeting at 7.
I mean, if people are, interested, I'm not going to kick them out.
No, I
Of
think
course.
It's good.
It's good? Yeah, that's good signs. Yeah, I mean, there was a lot of content, but I don't know if... I tried to structure in a...
It's spread it down more. Spread it down.
Yeah.
You don't want to run out of content halfway through the workshop.
No, yeah. Yeah, I guess I will open with the input components in the next one.
And you can speed it up a little bit if you want. If you don't think you're gonna get to the second workshop, you can speed it up. And if you see that at one point you're like, oh, I think I'm ahead, then you slow down, bring some topics up. That's usually what I do. If I think I'm going too fast, I'll slow it down, bring something up.
But the thing is, how you did to, because we uploaded all the projects at once.
You know, sign me up for the next class how to put this away correctly.
It's fine, don't worry. I got you.
Yeah, that's the hardest thing.
Oh, sorry. Oh my gosh.
The thing is that for him, oh my God, pobrecito.
I'm putting what?
No, not at the GBM, at the onboarding. Oh my God.
Remember Davian?
Davian was like talking and he was like,
Hey, you
sorry
talk?
guys.
Oh yeah, I was here, yeah. I remember, yeah.
That was so bad for him.
But now,
Me right there when
but I'm glad it's happening at the last one.
his phone, I don't think he was
I like ran to get him water.
I'm gonna ask you in the tables where it's going on. How is it going? Close?
Yeah, we're learning how to like fade the yellow, like the
Okay, yeah. With the PWM, that's fine.
but he's kind of like
Is it working the yellow or not still?
Oh, I haven't uploaded.
Not yet. Oh, okay, don't worry. Work on that. Yeah, sounds good. How is it going here? Good?
Do we delete all the other shit? The randomizer?
The randomize? Oh yeah, because you're supposed to open like for every project like the a new file. You need to copy everything. That's why I took so much time to put for you guys. Nah, don't worry, it's fine. But because if not, because there is one table that ran into the same problem. Like they were copying it, and they had like 2 void setup, and it was crashing.
Well, I haven't been doing that. I was reading through it.
But if you go to Explore Hub, it's just the drop down. You download the file and just open it as a new thing. For next time. Yeah. For next class.
Do you want to help us?
Yeah.
Right?
Yeah. Let me see. So first, what I noticed, you're missing a semicolon after the analog right
This?
here.
Not bad.
Don't worry.
Do I need a semicolon for these?
Oh yeah.
Oopsies.
Don't worry.
So, like, instead of talking about high-low, you can just already set it
Okay.
to the
doesn't show you when
states.
you have an error.
Wait. So this is the right.
This was like the first
Wait here. So you are turning on the red, which is fine.
analog,
You turn off.
right,
Wait.
and then we're gonna do
No, you're right. You turn on the green. I mean. Right, you turn off the other ones. Then you need to because you want the effect of like green, like a real traffic sign. Light, like
Red and yellow.
yellow and it's fading away, and then red. But red alone. Only red.
you can name it whatever you want.
So what you need to use here is like for in brightness,
Variables to store like because you'll see it here. So
brightness, yeah,
to your red LED.
good catch.
Analog
Analog
right,
right.
right
I want to preface, I'm not a coder, y'all.
No, don't worry.
We're gonna do red.
The pin is the red LED, which is already...
Analog right. This looks good. Brightness, but you understand what is going on here, like in the 2 loops.
So what I'm doing
Yes.
with
This
Like
one
here
is
in the
for
2
5
for loops.
seconds. Oh.
What is going on there? You
red
understand?
is already
Kind
255.
of like
This
So
is
red is already
turning
Because
up the
I
brightness.
really want you to
like
understand
this.
like the programming part.
This one is lowering the bright.
minus
I don't know exactly. I think it's like
Right.
like the yellow like
and then when brightness is
So this one you can see that it starts at, we are initializing at 0,
and then
right?
slowly like progressively get it to 20 to 25.
Exactly, like
55.
fading, exactly. And our condition is up until 255, including 255. So we're gonna have like from 0 all the way to maximum power, like with smoothly, because we added like a delay
Okay,
thing
so
to
that's
make
what,
it.
That's what this is.
Exactly. So you're doing it. You are calling the analog right, which is for PWM, which is the special case of digital signals. We are passing the first argument, which is fine, the yellow LED, and the second argument is going to be basically our value, our
So we
brightness.
don't have to put brightness in anything because it's already here.
No. It's fine. It's fine. Actually, you need it because that's why you are calling. You are declaring the variable brightness, and then you're using it for that function.
This is just like yeah, this is just declaring it. This is just calling it, right?
Exactly. Basically, you are like
So how do
exactly.
we repeat the cycle?
so now you can do
And then, no, I mean, that's on my end. No, 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 you don't need to do anything. Just try to upload it. I think it will work.
Oh, it should.
Green. Oh
So
my
bright.
God, wait.
Now we have to wait.
Oh my gosh.
Okay, word.
Yellow.
Supposed to stay on though?
Yeah. There you go.
Yay!
Let's go. We have here one project, guys.
But yeah, right? How do we do it where like the green
Yeah.
shuts off when the yellow goes, or is it supposed to be like that? So if I get like a real like.
I mean, wait, I forgot how a traffic light is.
It's green and then it goes yellow, and then it, like,
Without the green?
Yeah. Because green is like to go like normally.
Okay,
And
so you
yellow's to
could,
slow down.
so how would you do it? That's a good
Wouldn't you
good
add one of
exercise.
these
Where would you add it?
before the brightness?
Okay,
So then you would
try it. It's just trial and error.
I'll think about
Let's go, let's go, let's go.
it. Okay, calm down.
Let's go. Okay, okay. I was cheering you up.
So you already did red, and then you did green. So now you want to do yellow.
The other tables, how is it going? Good? You could do it? Let's see. Oh wow, I think it's working. Oh no. Wait.
Wait.
Oh wait. I'm impatient.
Wait. There we go. No, you lost it again. Wait, 5 seconds.
Wait, let me see.
It's the yellow, the one that has to go in and out.
The thing is, the yellow and the red shouldn't be like at the same. Turn on the same.
No.
Let me see your code. Oh wait. So. Oh wait. So first we need the green.
Oh, forget about it.
Oh wait, okay, wait. I think
Exactly.
But it's yellow, the one that has to go in and out. Where the
Look at
green
this.
part-
Turn green LED on 5 seconds. Red and yellow off.
Ah, okay,
How do you
okay,
do that?
okay. Well, I do.
What would you
this.
do?
High, green lit high, and then the yellow and the red off.
Start typing. You're gonna forget.
But am I right?
I think so. Let's try. Everything is trial and error here. Trust me. This is a way of learning.
follow their orders.
How is it going here? Good? Ojalá, bro. Pero no me dejan.
¿Cuánto por el kit?
¿Y cómo estuvo? ¿Le gustó?
¿Cuánto
¿Todo
por
bien?
el kit?
Sí. Pasa que estoy estoy casi enfermo. Chao, bro. Nos vemos. ¿Terminaste?
Once you guys are done, try to pack
¿Sí?
everything as
Bien, pibe. Ya tenés el primer proyecto, paila.
Se lo doy a este brother.
Nice. ¿Aún no tenías green? Bien. Bien, bro. Bien.
Are you done with the workshop? Because you're still on.
I'm still on?
Yeah.
It's fine, but I'm helping people. But if you want, you can
Oh, okay.
shut it down.
So, okay, yeah. Okay. 'Cause
And I can
I was
say,
like scared because you were having a side conversation. I didn't want that.
no, don't worry. Everything, I'll come back. You know,
¿Cuánto por el kit?
1,000. Do you want me? Do you want me to? All right. So this is my final words. You got it to work? There you go.
Yeah, we just had to turn it off after the delay.
So you got it. Nice. Okay. Well, hope to see you next workshop. Because we're gonna be doing input stuff, buttons, everything, remote controller. All right, guys. So wrapping up. So you can finish your project. No one is gonna kick you out. But thank you all for coming, and I hope to see you all in the next workshop. We're gonna be doing now interacting with the environment. You're gonna start interacting with the robot itself, like with the buttons, and we're gonna be using even wireless communication using infrared sensors. So that's gonna be cool.